And our last section here, we talk about conditional statements, their inverses, and their contrapositives. Of course, we'll also talk about the converse. So long story short, we have this conditional statement and the converse, which just mixed up this and that. Just switching the two kind of parts of the statement. Then we have the inverse and the contrapositive. So an inverse, what it does is it changes the sign of each part of the original statement. Sorry, didn't mean to write that. Of the conditional statement. So when I say sign, I'm meaning if the conditional statement is saying if this, then that, the inverse is saying if not this, then not that. See how it's completely related to the conditional statement. The contrapositive, I call it the converse of the inverse. So it's just switching up the statements of if not this, then not that, to if not that, then not this. One thing for you to make things easier, and at the same time, I'm not trying to trick you. This is your order. Sorry, I'm trying to write with my keypad, trackpad. So it's taking longer than I need to. I'm always going to ask you questions in this order. The conditional statements, its converse, inverse, and the contrapositive. That's all. That's all I'm going to be doing. So what we're going to do is we're going to do some examples, obviously. So the first thing we're going to do is we're going to state the inverse of this statement. State the contrapositive, determine whether each statement is true or false. If it's false, we're going to provide a counterexample. So the first thing we're going to do is we're going to do the inverse. The question is, if you live in Saskatoon, then you live in Saskatchewan. The inverse of it, so the inverse just changes the sign of the conditional statement. We're saying, if you don't live in Saskatoon, then you don't live in Saskatchewan. I'm just going to move that over slightly. Now, it is also asking if the statements are true or false. This one, hopefully you know it's false. Any kind of counterexample could be anywhere in Saskatchewan. Just because you don't live in Saskatoon doesn't mean you don't live in Saskatchewan. You could live in Lloyd. You could live in Elbow. You could live in Eyebrow. You could live in Armpit. I think so. Can't remember. But yeah, there's a whole bunch of other towns and cities in Saskatchewan. The contrapositive is the converse of the inverse. So it's just switching up the statements. So instead of if you don't live in Saskatoon, then you don't live in Saskatchewan. So it's just switching up the statements. If you don't live in Saskatchewan, then you don't live in Saskatoon. Is this true? Yeah. There's no other Saskatoon anywhere else in Canada or the world, which is different than actual Grenfell, but we'll talk about it. There's actually different towns called Grenfell. Yeah. Fun. That's actually all that question's asking. Oh, forgot to dash. All right. Next example. Arizona, not the state, so someone actually called their kid Arizona. Just like some people call their kids Alberta. But anyway, studying the color wheel in art class, she observes the following. If a color is red, yellow, or blue, then it's a color, then it's a primary color. What's the converse? What's the inverse? And is a statement biconditional? If it is, we'll state the biconditional statement. Alrighty. Hey, so write the converse of it. So this is just saying if a color is primary, then it's red, yellow, or blue. Is it true? Yep. Unless you're talking about light, but we're talking about art class, so we're talking about art primary colors. B, write the inverse of the statement. So the original statement is if a color is red, yellow, or blue, then it is a primary color. The inverse of it would be just adding or changing the sign. So if a color is not red, yellow, or blue, then it is not a primary color. Is that true or false? Yeah, our red, yellow, and blue are the primary color. So if it's not red, yellow, or blue, then it's not a primary color. Is it biconditional? Yes. Why? Just kind of bringing back to last day, the conditional statement, which is the original statement, and the converse, because they're both true. Colors red, yellow, or blue, and it's primary. Yep, that's the definition. Because that's true, and because its converse are true, then it's biconditional. Now we're going to state what the biconditional statement. So different ways that we can write it. The colors, red, yellow, or blue. So I'm going to change that very slightly. A color, red, yellow, or blue. Color is red, yellow, or blue if and only if it is primary. Is a primary color. Just as a FYI, another way that this can be written in math speak is like this. Instead of just that double-sided arrow, sometimes they'll use this one, but that's just kind of an extra bit of information. I think that we have one last example. Right. Write the following statement in all four forms. Is the statement biconditional? And we'll explain. There should be a period at the end of there. Alrighty, let's do some stuff. So we're going to write them as a conditional, a converse, inverse, and a contrapositive. So first off, writing this as a conditional statement. When you do not study, you will fail. So if you do not study, then you will fail. The converse, switch up the statements. If you fail, then you did not study. The inverse, is the taking the negatives or this changing the sign of the conditional. So because this already has a not in it, let's move that slightly over. If you study, or if you do study, you could say that, then you will not fail. So it's just taking this conditional statement and changing the sign. So it's the first part has a not, so we change it to a do. The second part has a positive, we have to change it to a negative on the other side. Contrapositive is just the converse of the inverse, so we switch up these two statements. If you did not study, sorry, if you do not fail, then you studied. Is a statement biconditional? So for biconditional, we need to look at these two things. And or for looking at our conditional and our converse, they both need to be true. So if you do not study, then you will fail. Is that true? No, there's people that don't need to study. At the same time, it's going to be very beneficial for you to study. You don't know how to study yet, you need to practice. How about if you fail, then you did not study? Oh, no, there's chances it could be trick questions and all that. But so that's false. Just because since one of them failed, since one of the conditional or the converse statement failed, it is not biconditional. And just for fun, finish off. If you study, then you will not fail. Well, you're just going to reduce your likelihood of failing, but still, it's possible. And if you do not fail, then you studied. Again, that goes straight back to that conditional statement. It's potentially false. Alrighty. So this is just that idea of adding that if a statement already has a negative in it, you have to change its sign. That means that you can go have some fun.